Hello there, fellow master builders, ready for the final steps on the way to the perfect LEGO building generator. In this last part of the series I will show you how you can use the building generator with corner buildings, how you can combine several buildings in a single row, and how you can easily use the asset browser at any time in any of your projects to access your buildings. But first of all, we will focus on the performance of our building generator, because believe it or not, there is still a lot to be gained here. If you followed the tutorial up to this point, then you've probably noticed that using Blender can become quite laggy when the building reaches a certain size. It may be sooner or later, but it will definitely happen at some point. I'll show you my computer specs here, so you can perhaps compare your system and your performance better to my results. If we start playback via the timeline, we can see in the top corner at how many frames per second our scene is currently running at. If you don't see this, you can activate it here under text info. In addition, we can increase the frame rate even further in the output properties so that the upper limit is not reached so quickly. We see that even though I have a pretty good system, I can no longer achieve full performance even with this medium-sized building. If I make it any bigger now, it will only get worse. I better pause playback for now. But why is that? If we also show the statistics, we can take a closer look. Here we see the number of objects, vertices, faces and so on that are in the scene. When I select an object, the total number of all visible elements is shown on the right and the number for all selected objects is shown on the left. Currently, both numbers are the same because I only have this one building visible in the scene. If we want better performance, we have to try to get these numbers smaller without making our model look worse. We have already taken the first steps, such as deleting the interior of the building directly in Mechabricks or importing the model without logo on studs. The building generator also takes advantage of the special properties of instances. Each floor in our building is just an instance of the original floor collection, like an exact clone. If we change something in the original, it will also change in all the copies. This has the advantage that all vertices, faces, etc. are only counted once. Just pay attention to these values when I change the size of the building. They all stay the same, except for the number of objects. So we can't improve much on the lower values without reducing the quality. But what about the number of objects? Each LEGO brick is an individual object. The larger your scene gets, the more LEGO bricks come into play and the more it affects the performance. And can I tell you something? Everyone is always looking at the number of vertices, but in my experience with 3D LEGO models, it is the number of individual objects in particular that causes the scenes to start lagging like hell at some point. And I feel like no one talks about it. I really only mean performance in the 3D view workspace. Render times are a completely different topic. But honestly, you usually only need to render at the very end of a project. And you can also leave it running while you are not actively in front of your PC. But working on a scene that is constantly jerky is the biggest fun killer of all for me. Don't you agree? So, long story short, let's reduce the number of objects. We go into our geometry node setup and add the node called Realize Instances. Before I insert it, I press play again. Look at the FPS and the number of objects and hold on tight as I add this node here. Bam! Only one object left and everything runs smoothly. Thank you and goodbye. Well, not quite. Unfortunately, this method does have a small, not entirely insignificant disadvantage. Using this option here, we can display the time it takes to process the individual areas of the node tree. We can see that most of the groups are in the low millisecond range. But then the Realize Instances node comes along and really packs a punch. So everything might run smoothly once it has been processed, but as soon as we even change a small thing via the interface, there are considerable loading times, which only increase further the larger the building becomes. Such a shame. So let's delete this node again. We would need a way to reduce the number of objects without having to use this demanding node. Luckily, there is another way to do this in Blender. If you have multiple objects in a scene that you want to merge, you can select them all, then use Shift left click to select the main object and then click here, or simply use Ctrl J to merge all the objects into one. This doesn't change the geometry, the materials, the vertices, etc. and yet we only have one object left, exactly what we want. However, this process is pretty much irreversible, which is why I waited until this point in the tutorial. So if you want to take this step now to massively increase the performance of your building generator, then you have to be sure that you no longer want to access the individual bricks in the future. But I know how it is. When is one ever absolutely sure about anything? That's why we can at least duplicate the entire collection beforehand and call it backup. So we still have the original objects if something comes up that we want to change in the future. For example, I only noticed later that when I wanted to render a scene that there were a few duplicated bricks at the roof, which resulted in clipping artifacts. So I'm getting rid of them quickly. And of course in the other roof variant too. One thing I also like to do for the bricks that are transparent, like the windows, I go to the material properties and here at viewport display under color, I turn the alpha value down a bit. It's just an optical detail and has no impact on how it will look when rendered, but I like it that way. Okay, now we can combine the individual layers step by step into one object. Unfortunately, the empties get in our way a bit. We can't just delete them directly because then the rotations and positioning that we have already done will be reset. The easiest way is to briefly activate all the layers, then move the mouse to this window and press A. Now that everything is selected, press Alt P and select Clear and Keep Transformation. This means that all objects lose their connections to the empties and still remain in their current location. Now we can search for empty up here and delete all the empties that are in the building collection. Be careful not to accidentally delete the empties from the backup collection if you haven't disabled it. If you have, they won't appear in the search results anyway. Good, now we can turn off all collections and work our way through. So we first activate the first collection, open it, right-click on the collection name and click on Select Objects. With the Control key pressed, we select the top object. Before we combine all the objects into one, there's one last important step. Down here in the data properties, you have to make sure that the mesh data from the selected object only appears once in the scene. If this is not the case, you have to click on the number. Now move the mouse into this window and press Ctrl J. Unfortunately, this may take a little while, depending on how many bricks you want to merge into one object. If your computer can't handle it at all and crashes, you would have to proceed in smaller steps and only merge a few objects together and then add more and more. Hopefully it will work for you with a large amount of bricks like it does for me. As long as Blender doesn't close completely, it usually continues to work in the background. When the object is created, we press Ctrl A and apply the rotation. This is important for a node that we will add later. It won't work correctly otherwise. We now have to do this with all the collections except the lights. So again, activate collection, select objects, control click on the object, make mesh data single user, move mouse into this window, Control J, wait, Control A and select rotation. Select new collection, select objects, control click on the top object, make mesh data single user, move mouse into this window, Control J, wait, Control A and select rotation. While you do this for the remaining collections, you should actually be able to notice that the performance is slowly getting better and the merging is also happening faster and faster. Now just the AC units. Done. And now look at this. A complete building generator that only consists of a few objects and runs super smoothly. The interface also works perfectly and without any long delays, like it did when we used the Realize Instances node. Guys, I'm telling you, this is pretty revolutionary. You can now transfer this knowledge to completely different LEGO 3D projects of yours. Whenever you have a scene with a lot of objects and you don't need control over each one, merge together what you can and enjoy your performance boost. So if this isn't worth a like and subscription, then I don't know what is. And do you want to know a secret? We can make it even smoother. With this node here, Bounding Box. Of course, not for the final export, but while you are working on your scene, this is a great way to still see what your scene looks like, how light and shadows fall and so on, without having to disable entire collections. I mean, look at these numbers. We went from tens of thousands of objects and millions of vertices to this, without having to delete anything. That's pretty incredible. I think I only see these black areas because of an option that I once activated. I think this one. Exactly. We can now quickly add a switch to the bounding box option. We are already practiced at this. If true, the bounding box goes in here. If false, the geometry goes directly in without the bounding box. We connect the switch to the input and call it preview, for example, or whatever you want. And that, ladies and gentlemen, is the complete building generator. I still have two variants up my sleeves that I would like to share with you and that are not difficult to implement. Just a small modification to control corner buildings, of which there are also some in the modular style. With these, it doesn't make sense to expand the row further outwards. Instead, it makes sense to build a circular shape. And to top it off, there is the wall. But more on that later. Let's start with the corner buildings. Here we can implement a few previously learned techniques and do it better than with our first building. The way I always do it now is that I create a variation for each floor directly in Mechabricks. I also move the floors around in this pattern, which makes it much easier for me to select the right objects for each floor in Blender. Just make sure that one of the ground floors is in the center of the scene. We can even copy the entire folder structure from our first building. To do this, duplicate the main collection again and call it building template. I disable the extras and the lights collections. Now I press A and delete the entire contents. For the extras I keep one AC unit from each design, and for the lights one of the white and one of the random lights. And to be honest, the abbreviations in the names of the collections are actually no longer necessary, since we only connect the top collection with the name of the building to our building generator. So get rid of it. This is now our template that we can use for every new building. We duplicate our template collection and give it the name of the new building. First, we check again whether we also have the front view in the front view. The corner building should be open to the right, so we can expand to the right side again. If we are happy with the rotation, we can now already delete the empty. So select everything with A, press Alt P, clear and keep transformation, and then delete the empty. Oh, and since we have already selected all the bricks, if you have Mechabricks Advanced, then now is a good time to set a small value for the randomness here. Something around 10%, I think 7 is quite good. This rotates the bricks a tiny bit and makes the Lego sets look a little bit more organic and not so perfectly assembled. Now we can easily select the first ground floor and move it to the correct collection with M. Before I deactivate the collection, I select the second ground floor and move it to the center position. Now I can deactivate the first ground floor and move the second one into its collection using M. The same goes for the floor above. Before I deactivate the second ground floor, I move the upper floor to the correct position, and I continue like this until all floors are assigned correctly. We don't have additional billboards in this building, so the folders can simply remain empty. Don't delete them or it will mess up the numbering inside of the geometry nodes. Do AC units fit on this building? Maybe here? You know what? I don't want to drag out the tutorial unnecessarily. You know how it works. If you want AC units or other extras on the building, you place them. Let's arrange at least a few of the lights. And with that, the preparation for our corner building is already finished. Didn't take that long at all, did it? Now we can deactivate the collection and duplicate the building generator object. We call this corner building generator. And here let's set the width to 1 and the height to 2. Now we select the collection from our new building here. And all we have to adjust here is the Z size. Set the height to 2 or 3 to align it correctly. That looks good. If this were not a corner building but a normal modular building, we would already be completely done at this point. But as you can see here, it doesn't work as it should. So we have to look at our geometry nodes again. Very important, before we change anything here, we first make a copy of the node group and also call it corner building generator. Then we can select all these nodes and combine them into a group. We can rename it, for example, in corner group. We no longer need the width as we used it before. Or we only need it with the value 1, so that the building can be seen in a single execution. We rename the width output in the group input to corners. And the way we create the corners now is super easy. We need a maximum of 4 corners. So we duplicate this group using Ctrl+Shift+D until we have it 4 times. The first group fits as is, so it can go directly to the output. The others will be added at some point, so we can connect the join geometry node right away. The second group moves to the right and must turn 90 degrees counterclockwise, so we connect it to a transform geometry node. So that we can see what we are doing, we connect it to the join geometry node. We need to move it to the right on the x-axis. How far? Of course exactly as far as our x size is. So we can put in a combine XYZ node and connect the x value to the x size from here. Now the rotation, 90 degrees on the z axis. Done. Ctrl-Shift-D this, and let's look at the third corner. This not only has to be moved on the x-axis, but also on the y-axis. How far? Exactly as far as on the x-axis. It's a square. How convenient. So we can also connect it to the x-size and rotate 180 degrees on the z-axis. Now the fourth corner. Ctrl-Shift-D, connect, and here we only need the y-axis and not the x-axis. Rotate the axis 270 degrees. Done. Now we need to be able to turn the corners on and off, so we need 4 switches. The first corner should be there if we set corners to 1 and above, or in other words, a value greater than 0. Good thing there is a mask node that can do exactly that, greater than. So if this is greater than 0, then this switch is true, so the first corner is visible. The second corner can be seen at greater than 1, so we make a greater than node with 1. With Shift and holding down the right mouse button we can create this, then we don't always have to go all the way to the left to the group input. The third corner is greater than 2. Connect everything, and the fourth corner at greater than 3. Ta-da! 2 more little things. Since all groups are connected to the same seed value, there is currently no real variation to be seen. We can fix this by connecting a math node to the seed and multiplying a different value everywhere. And the last thing I like to change is a little variation for the height. If you put a math node in front of the height of the second corner group, set it to add and connect it to the group input, we can make one of the corner buildings appear a little higher. Set it to integer here. We can call this extra height or something. I think that's pretty cool. If you are happy with the result, you can now merge the individual objects of the different levels together for the performance boost, as we did at the beginning of the video. The corner building generator is now finished. Before we slowly come to an end with this series, I have one last cool variation of the building generator for you. I call it the wall. Once you have added several different modular buildings to your building generator, you can group them all together and create randomly generated blocks of houses super quickly. And it works like this. As I said, you first need a few prepared buildings. The more the better. These can be modular buildings that are open to the left and right, but corner buildings can also be used for this. We take our original building generator object and duplicate it. I hide all the other buildings. And rename the new one. The wall. Very important, we also create a new node group in the geometry nodes by copying the old one and calling it the wall. Similar to the corner buildings, we put everything in one group again. We can rename it, for example, in wall building. Again, we are changing the way we handle the width. So we break this connection here and make sure that the width value is set to 1. Since we will be using many different building models, all of different heights, the single Z size we have so far is no longer enough. So we also separate this connection. Since we have several buildings, one building collection is no longer sufficient. That's why we are renaming the existing collection B1 for building 1 and move it to the bottom here. So that not all buildings have the same height, we put a math node here in between. We leave it at add and can initially leave the value at 0. And so that not every building has the same seed value, we also place the math node here that is set to multiply. You can insert any number here. Now we can duplicate these 3 nodes with Ctrl-Shift-D until you have them as many times as you have prepared different buildings. In my case there are 6. So duplicate 5 times. Each new group now receives its own building collection input. I named them B1 to B4 for the normal buildings and then CB1 and CB2 for the 2 corner buildings that I made. We can change all the values in the math nodes for the seed. Now we have to select the right building collections everywhere. The order doesn't matter, just make sure that if you have corner buildings, you also select them in the CB groups. Next, we need to set the appropriate Z size for each group. To do this, set the height to 2 and find the right value. For the first building, it's still this one. When we connect the output to the next building, we can check whether we are doing everything correctly. We can pin the current node tree up here, then it won't disappear when we select another object. So we can simply copy and paste the Z size values from the other buildings by selecting the building generator objects here, provided you set it correctly when you created them. For better organization, we can completely remove the Z-size input from the wall. We don't need it anymore. Now we can join all these groups together, not with a join geometry node as usual, but with a geometry to instance node. We don't want all the buildings to become one big mess, but we want to be able to make the individual buildings appear next to each other with an instance on points node. We connect instances to instances, the output to the group output, and we can activate pick instance. Now we have to determine how the points should appear next to each other. For the individual floors, we did this with a cube and used its z-axis for the height and its x-axis for the width. For the wall, we only need the width, and that's why we can use a mesh line node this time. Make sure endpoints is selected here and count is selected here. For count, we set 2. If we now connect this to the instance on points node, then we can see that we can use the end location to specify both the direction and the length of our line. With the count, we determine the number of buildings, so we can connect this input to the width. So we don't always have to draw such long node connections, we can add an additional group input node. This makes it easier for us to reach the sockets. We connect width to the count and set width back to 2 here. We determine how far we want to move to the right on the x-axis using the x size. We can transfer this value with a combine xyz node. If we increase the width, the x size must also increase, so we need a math node on multiply and multiply the x size by the width. Not the complete width, but the width minus 1. And now we can set the height and the width in the modifier properties. We can also connect the instance index again to a random value node that is set to integer. For max, we can set any number as high as we want. Only the maximum number of buildings available will be selected. We create a new input for the seed. So we can have the old seed value for the ordering of the extras and the new one for the ordering of the building models. I think that's better than just one seed value for both together. That looks pretty good, but what is of course still noticeable is that the corner building in the middle of the row makes very little sense. It would be more correct if it only appeared on the outside. We can do this using the selection input and an endpoint selection node. However, this only works if the points are on a curve and not on a mesh, as is the case now. So let's add a mesh to curve node here. Now we can use the start and end size to display only the first and last points, or if we put a Boolean math node that is set to not in between, all points except the first and last ones. Let's set 1 for the start size and 0 for the end size. Now we detach our corner buildings from the group and duplicate all of these nodes with Ctrl-Shift-D. We can break these connections and let's connect the corner buildings with this input. We don't need the second group output node, but we connect the two groups with a join geometry node. If we now remove the Boolean node, everything works as we want it to. There's always a corner building in the first place and the normal ones after it. You may be wondering why we didn't also add a corner building to the end of the row. If you imagine that you are building a complete street set that also goes around the corner, it is better if the end remains free. Then you can duplicate the entire wall, move it to the end and rotate it by 90 degrees on the z-axis. And you will immediately have the perfect connection. Change the seat a little bit on the other wall, done. This makes it quick and easy to create entire blocks of buildings. If you want, you can leave it at that. If you want some variation in the height distribution of the buildings, I have a solution for that too. It's not particularly elegant, but it works. Simply duplicate the group of buildings for which you want different heights. And use the math node connected to the height to enter an alternative value. Of course, we can also change the seat value slightly. As you can see, this building can now appear with two different heights. You can then, for example, with the higher version, disconnect the billboard connections and always leave it activated. To be on the safe side, perhaps a little higher so that there are no overlaps. But that is entirely up to you. Of course, you can do this with as many building types as you want. Theoretically, you can also create a wall with just one type of building which has many different heights. Simply duplicate the wall object, create an own node tree and remove all the other buildings. If you don't want any other corner buildings in there, you can also remove the endpoint selection node. Instead, we can incorporate even more height differences with the same type of building. Apart from the height differences, this method is a bit more limited than the original building generator. As you can see, all buildings with the same height always have the same arrangement of extras. Still, it might be good to know that this option exists. Once you've got all that done, the final step I'll show you is how you can integrate your building generators into your asset browser so that you can easily use them in any of your future projects. To do this, we first go to Edit, Preferences and then File Paths. There we have the Asset Libraries section. All you have to do here is add a new category with the plus and then specify the folder in which you save the project file. It is not necessary that all assets are created in the same Blender project. It is only important that all project files are saved in the correct folder. As you can see, I already have a library for Lego. We can now make an asset browser window. Up here you can select the category you want to see. With this plus you can then create additional subcategories within a category. You can see that I have one for cars and lights and also for the building generator. There you can see the buildings that I have already created. Now let's add the wall together. To do this, I first set the modifier properties as I find them suitable for the start. So for example, seat to 1 and the height and width to relatively low values. Lights off and all the extras of 2. All you have to do now is right-click on the wall object and then select Mark as Asset. If you now scroll down to Unassigned, you should be able to find the new asset there. You can now grab it and move it to the correct folder. Don't forget to save your project. Now we can open a completely new project. We open the asset browser and now we must select how we want to import the building. You have the following options: link, append, and append reuse data. Follow preferences is equivalent to one of the bottom 3 options and is set here in the preferences. If you select append or append reuse data, you get this nice preview that shows you where the building will be placed. But the import with this option takes relatively long and is pretty messy. All collections appear and they are activated even if they weren't actually activated before. All in all, not very practical. The best option is link. This means you lose the opportunity to place the building nicely with that preview grid. It now always appears in the world origin, so at 0, 0, 0. But that way really just adds the building generator object. All we have to do to be able to edit it is click on this icon on the object properties. It cannot be moved or edited beforehand. But once you click on this, everything works as it should. Easy peasy. I hope you enjoyed this tutorial series. I hope you learned something, maybe even about geometry nodes in general, and I'm looking forward to all the stuff you will create with this new knowledge. Make sure to comment, like and subscribe if you want to support me. Also, you might want to check out my Spiderweb add-on if you want to fill your new city sets with some web slinging action. See you in the next video.